All. This is Dr. Mobeen Sayed from drbeen.com. As promised yesterday, we are going to talk about the omega-3 fatty acids today. So let's start. The basic concepts to keep in mind is that number one, it is important to have omega-3 in our daily food intake. Number two, omega-3 can be found in fish and in plant sources or seed as well. However, the amount that is found in the seed or plant is little, and so you may have to take supplements. So this is especially for those who would be vegetarian. Then the function of the omega-3, there are multiple functions and there are a lot of things that are that are these substances that do. The discussion that I want to focus on today is especially the anti-inflammatory effect of the omega-3, which is relevant to the COVID-19. And as you saw with Dr. Marek's Math Plus protocol, in the post COVID syndrome, the condition that we call long haulers, he has prescribed or suggested to use omega-3 to reduce inflammation. So I want to make sure we can look at that mechanism to understand how does that happen. So this is the gist of the discussion today. Let's start the discussion and welcome everyone. Cool. So I'm going to share my screen and let's start. Right here at the top, there are some of the links that are present in the description. So this is on Wikipedia, what is omega-3s. Then this is the effect of omega-3 fatty acid oxidation production products on the cellular and mitochondrial toxicity. Then mechanism of the science behind dietary omega-3 fatty acids. This is a very, very important topic. I would like everyone to read this. This is cardioprotective mechanism of omega-3 polyunsaturated fats or fatty acids. And then here is the nuclear factor kappa B, which is important, and this plays a role with fatty acids as well, omega-3 fatty acids. So having said that, let's start our discussion. First of all, these are fatty acids. So these are fats. Omega-3 oils, they are also called, the omega-3 fatty acids are also called omega-3 oils or omega-3 or omega-3 FA or N3FA, or FA standing for fatty acids. So these are different names, and there are various types of these as well. For example, in the case of fats, there can be unsaturated fats, and then there can be saturated fats. And within the unsaturated fats, there can be monounsaturated fats or polyunsaturated fats. So we are talking about polyunsaturated fats today, which are, or polyunsaturated fatty acids, which means this is called PUFA, polyunsaturated fatty acids. So saturated fats are dangerous. However, unsaturated fats are good. And then monounsaturated is a separate topic. We're talking about polyunsaturated fatty acids. What does that mean? So if you see here, this is a fatty acid. This is a structure of ALA. Now over here, if you see these little bars here, these little kinks in the diagram, these bends represent carbon. This is just a way to write it. They are actually not bends. This is that every single bend is a carbon atom. And then with that, there are various things that are attached. And remember, one carbon atom can have 4 bonds attached to it. So if you see here, this is the alpha end, and this is omega end, or the end of the fatty chain. In this case, for example, there are 18 carbon atoms. The last one is 18th. And then if you count from the last one and keep going into the earlier carbon atoms, you would see that here at the 3rd carbon atom, for example, this was the first one from the last, that is 18th. This is 17th. This is 16th. And this is 3rd carbon from the end, the terminal part of the fatty acids. That 3rd carbon has a double bond in it. So that means that that carbon, instead of having all 4 bonds saturated or all 4 bonds fulfilled, there is one bond that is not fulfilled, and there is a double bond there. So that is the polyunsaturated. Why do we call it polyunsaturated? Here is one unsaturated bond, then here is another unsaturated bond, here is another unsaturated bond. So this is poly. Poly means many. So this molecule over here has many unsaturated bonds. If there was just one unsaturated and other, this was not, this was saturated and this was saturated, then that would be called monounsaturated bond. So I hope that that clarifies the concept of polyunsaturated bonds. So this is Ella, which is omega-3. It is a polyunsaturated bond. All right, so let's continue. What is the daily adequate intake? So we would see that a little later that the sources or the types of omega-3 are either from the plant source and plant and seed source, or from the marine or the seafood. And the one of those is called Ella, that is from the plant and seeds. And then the marine is called EPA and DHA. So first of all, please realize this, that Ella cannot be synthesized in our body. So we have to eat it. So that means either we take the fish or we take plant or seeds. But Ella would, if you need Ella, you need to have plants or seeds. Ella cannot be synthesized. Although if we have Ella present in the body, so that means let's say you ate seeds and then Ella is now available in the body, Ella can then be converted to EPA and DHA, which are the plant sources, and DHA is actually the active form or more active form, if we can say so. So EPA and DHA can directly be consumed as well by consuming seafood. So if you are a vegetarian, then you'll have to eat Ella, and that would then become converted to EPA and DHA. If you are not a vegetarian, you can directly take seafood, which will give you EPA and DHA directly without going through the Ella route. Finally, it is also possible to take fish oils, which are the supplements. However, it is always great to have the actual food. But if you cannot have the food, for example, if you're vegetarian and the amount, I'll show you, the amount of food needed to have the right quantities is a lot, then you can go for the supplements as well. Now, the adequate intakes for Ella is 1.6 gram per day for men and 1.1 gram per day for women. EPA and DHA, 3 gram per day or maximum 4 gram per day. And please, for EPA and DHA, there are actually no adequate daily intakes, but it has been said that 2 to 3 gram per day is safe thing to take. What is the danger in it? The danger is this, that in men, taking 4 gram per day or more. So let's say you have fish oil capsules hanging around in the home, and you say, you know what, I'm going to just take a lot of these because these are anti-inflammatory. If you take 4 gram per day or more, that is known for men. It is known to increase the risk of prostate cancer by about 43%. So don't take a lot. Yes, so James has a question. Sorry, but I assume Ella is alpha lipoic acid. I think it is alpha linoleic acid. Suggested supplement. I know certain scientists. Yes, absolutely. So then, American Heart Association says that eat fish twice a week to get enough DHA and EPA that is cardioprotective. So this is about the daily intake. Now the sources. Sources, Ella, main sources, these are plant and the seed sources. So these are chia seeds, flax seeds, walnuts, spinach, and avocados. There are more as well, but these are important ones. Now keep this in your mind. So this is the practical part of it. If you are taking Ella, because let's say you're vegetarian, then you have to take 9 times more amount compared to DHA or EPA. So for example, if you're going to take 500 milligram of EPA or DHA, then you need to have 4,500 milligram of ELA. So that is the potency difference. And secondly, when you are taking food that may have ELA in it, here are some conversions that are interesting to keep in mind. Flax seeds, 2 tablespoons are enough for the daily ELA intake. 2 tablespoons, sorry, this is tablespoon, 2 teaspoons of flax oil, flax seed oil is sufficient for daily intake. Half cup of walnuts is sufficient for daily ELA intake. 27 cups of cooked spinach daily is sufficient for that. So this is their equivalent amounts, that either you take 2 tablespoons of flax seeds, or for the same amount of ELA, you need 27 cups of cooked spinach. 27 cups daily of the cooked spinach. So let me know when you're doing that. I want to come see you. And then if you want to take avocados, for example, and you want to give the same amount of, you want to get the same amount of ELA as 2 tablespoons of flax seeds, which is the daily need, then you would need to eat 26 medium avocados. So 26 avocados or 27 cups of cooked spinach sounds interesting. So this is the vegetarian side. Now on the seafood side, oily fish contains the omega-3s. So what are the kind of oily fish? For example, salmon, mackerels, herring, and I try to draw them, anchovies, menhaden, and sardines. These, and there are more seafoods, but these are the important ones. And finally, fish oils. So if you see here, I made this little capsule, which really looks like a capsule, the fish oil capsule. So fish oil capsule, krill oil, eggs, meat, etc., they also have them. If you want to control the quantity precisely, then fish oil capsules are fine. They, I believe, come in 2 types, esters and glycerol formations. The studies do not show any big difference between them. So it doesn't matter which type, which form of the capsule you are taking, they both are effective and fine. Now, here is an important thing to keep in mind. It is possible that some fish may have these kind of products like mercury or lead or nickel or arsenic or cadmium. So if you are pregnant, then please be careful for the kind of fish. Where is it coming from? Some cold water fish or freshwater fish have these metals, and that can be toxic to the baby developing. So in that case, taking capsules may be the right approach, because when they develop capsule from the fish oil, they do a lots of purification and cleaning of them from the metal parts. Now, continuing to the functions. So Jim says that keep fish oils in the freezer, correct. There is another comment here. 1, chop up sardines with lots of finely chopped celery and a spicy mayo made with avocado oil on toast. Wow, that is awesome. Send me some as well, France. So, okay. JTJ says it's 810 grams of spinach, but as powdered spinach, it's 81 grams, and spinach pasta is 10% spinach powder. So 810 grams of spinach pasta will work. So just want to make sure that these messages are coming across as well. James Kelly says, you are a true artist. Love your explanations and drawings. Thank you very much. Much easier to remember. Yeah, that's what I thought. Whenever I'm drawing, that is in the back of my mind. So functions. And again, I'm not going to drill down into every single function, but important function from the COVID-19 point of view. Remember, Dr. Paul Marek says that for long haulers, taking fish oils would be very beneficial as an anti-inflammatory. So see here, number 1, fish oils or omega-3s reduce the production of VLDL in the liver. So that is cholesterol related. So good thing, reduce VLDL. And we know that inflammation and atherosclerosis can occur because of the VLDL type of substances, which can go in the blood vessel walls, and then they get oxidized there. Then macrophages come in and they eat them, and then they become foam cells, and then the immune system response starts for the local inflammation occurs, and the blood vessel becomes thick, not thick, it becomes stiff and atherosclerotic, and then plaque develops, hypertension occurs, and strokes can occur. So all of that can be reduced, the risk of that can be reduced by omega-3s because they are known to reduce VLDLs. They also increase the fatty acid uptake and beta oxidation of lipids, the fatty acids, in heart, adipose tissue, and skeletal muscles. So again, anti-inflammatory effect. Then this is an important one here. They reduce cell membrane stiffness. So this is a general mechanism for cholesterols or fatty molecules, that this flexibility in our tissue is because of the fluidity of the cell membrane. And that fluidity is important not only for the flexibility of the tissue, but it is also important for the function of the proteins present in the cell membrane. So think about cell membrane as an ocean, and the surface of the ocean is the surface of the cell membrane. And there are ships in it, and there are boats in it, and there are other things floating around. Those floating around things, the ships and boats, are proteins in the cell membrane, and they need to do their function. And for that function, they need to be able to move around and swim to other parts of the cell membrane and do their function. Similarly, some of these proteins are going to take part in signaling mechanism, which means that some substance or some signal arrives at a cell. For example, when somebody comes at a door and presses the door, what is that? The bell button. Similarly, these proteins can act as signaling molecules. So they need to be in a flexible environment where they can easily change their shape and function. So if the cell membrane is not flexible and not fluid, the functional parts of the cell membrane will not work correctly. Imagine a door in a wall. If the wall is too stiff, the door might get stuck in the wall and not operate correctly. So the fluidity of the cell membrane is really important for a cell to function correctly. This also is connected with the aging. As we age, our cell membrane's fluidity start reducing, which causes the function to start going down. So here, if you see, I've created this little raft in the cell membrane. This is omega-3s. So imagine this is the phospholipid. Remember, the cell membrane is made up of phospholipids. These green parts outside are phosphates, and inside are phosphates. Then between the phosphates are sandwiched the lipids. So imagine that we have a sandwich which have two slices. These two slices are going to be called phosphates, and the mayonnaise in the middle, or the butter, or whatever else you have in the middle, that will be the lipids or the fats. These fats are usually compressed together and they join together, and that causes reduced stiffness, reduced fluidity of the cell membrane. When we have cholesterol in the cell membrane, or when we have omega-3 like substances, omega-3 have, if you see here, omega-3 have a kink in their structure. They have a bend in their structure. So this is, imagine if many people are standing together, and if they're standing straight, they would all be very close to each other. But imagine if every one of them kind of pushes the other one away because they have a bend in their arm, and they kind of open it like this. So now there will be a distance created between the people. That would create more space, and that would create more fluidity. So this is what we have over here, that the omega-3 have a bend in them. So when these lipids accumulate or are present in the cell membrane, that creates fluidity in the cell membrane. This fluidity is important for local rafts and caveoli. What are the local rafts? Believe me, cell membrane actually acts like an ocean surface, and the protein clusters are swimming in it, or they're floating in it. These are called local rafts, and we need them to function correctly. Similarly, caveoli are small cave-like structures in the cell membrane through which various substances can pass, and the caveoli function has to be very correct. And remember, one of the caveoli function we saw a few days ago, that was for the cellular movement from the blood vessel outside immune cells. And secondly, caveoli can be functioning to improve the phagocytosis. These are caves. Similarly, in blood-brain barrier, we saw that caveoles are used for the movement of some of the particles from the blood to the brain. So if caveoles are not functioning correctly, all of these things would have an effect, negative effect. So local raft and caveolar function of the cell membrane needs to be correct, and that is done by omega-3. Omega-3 also helps reduce production of interleukin-2 and the protein kinase C. Interleukin-2 is an inflammatory protein, and then protein kinase C is a signaling molecule. This is like the doorbell which you press and something happens inside the cell. So the doorbell has to be healthy. And for that, the cell membrane has to be fluid. For that, we need cholesterols and omega-3s. Similarly, in our heart, the ionic channels, especially the sodium channel, its function is made or improved by the omega-3's presence, and the sodium channel becomes stable in the presence of omega-3 in the cell membrane. So sodium channel is also in the cell membrane. Imagine sodium channel is like a door in the wall. So when the omega-3 are present, that door functions in a more stable way, which is an anti-arrhythmic effect. So people who are prone to arrhythmias may benefit from omega-3 because omega-3 protect against arrhythmias by stabilizing the sodium channels. Then anti-inflammatory effects. So this is directly related to long haulers. And that is, imagine this is a bacteria or a virus. These bacterial products or viral products, when they interact with a cell, the cell will have the nuclear factor kappa B gene activated in the nucleus of the cell that is under stress. And that would produce nuclear factor kappa B. That nuclear factor kappa B in turn would cause cytokine production. We have been talking about this since the vitamin D days, because vitamin D helps with the modulation of nuclear factor kappa B. The fish oils, not only they help with the production of vitamin D, they also help produce a similar effect like vitamin D, and they modulate the nuclear factor kappa B gene expression. That causes reduced cytokine production, which causes reduced inflammation. So what is the effect here? Presence of omega-3s in a stressed out cell would reduce the production of nuclear factor kappa B gene expression, or would reduce expression of nuclear factor kappa B, which would then reduce the production of cytokines, which would then reduce the inflammation. Beautiful mechanism, an important mechanism. Then omega-3s in macrophages and dendritic cells, they block the production. So again, they would go into the cell's nucleus and reduce the gene expression, and they block the production of interleukin-1, 6, and tumor necrosis factor. And again, we have done immune system discussions so many times. You know that interleukin-1, interleukin-6, and TNF are related to amplifying the immune system response. So presence of omega-3 reduces the innate arm of the immune system's function, suppresses it a little bit, modulates it a little bit, reduces the inflammation. And this is what we want. So that is a very important function. Then omega-3s increase the production of nitric oxide in endothelial cells, which causes the blood vessel dilatation, which is an antihypertensive effect, plus it is a cardioprotective effect as well. They reduce fibrosis in the heart. So somebody who is a cardiac patient, heart patient, and if they are prone to have cardiac damage and fibrosis, omega-3 are known to reduce the fibrosis by modulating the TGF-beta-1 gene expression and reducing the formation of fibrosis. Similarly, omega-3 can actually help improve insulin resistance. Folks, my apologies, people who have chronic inflammations, for example, autoimmune diseases, they may become insulin resistant because the chronic inflammation causes the GLUT4 channels in the adipocytes. The adipocytes are the fat cells. GLUT channels are the glucose channels. So these glucose channels become resistant to insulin, and the normal insulin function and the glucose metabolism becomes disrupted, which then causes diabetes. So presence of omega-3 actually improves the function of GLUT3, which then reduces insulin resistance and reduces the chances of and severity of diabetes. So that is also a very important function. And finally, this is really important. If you can take away one thing from this whole talk today, that is this slide. And this is, imagine once again we are at the cell membrane. Cell membrane is made up of phospholipids, bilayer. Inside the phospholipids, there are arachidonic acid sitting there. And arachidonic acid is also a fatty acid. It is an omega-6 fatty acid. So that means that the double bond, it is a polyunsaturated fatty acid, double bond appears at the sixth carbon from the end. Omega-3, when present, will get into the cell membrane, displace the arachidonic acid, and take its place. So that causes a profound anti-inflammatory effect or reduced inflammatory effect. And how does that happen? Number one, when omega-3 becomes part of the cell membrane instead of omega-6 or arachidonic acid, then the products of the arachidonic metabolism that are made. And just to review very quickly, the metabolism, we have actually talked about it in detail with aspirin in that video. Remember, we have phospholipase A2 enzyme. Phospholipase A2 enzyme causes the arachidonic acid to be produced from the cell membrane phospholipids, which means this omega-6s. Then the arachidonic acid will have cyclooxygenase or lipoxygenase enzyme act on it, which then would cause the production of prostaglandins, prostacyclins, and leukotrienes. And some of these are anti-inflammatory, some of these are pro-inflammatory, some are vasodilators, some are potent vasoconstrictors. Normally, when this pathway becomes active, we get inflammation. When arachidonic acid is replaced by omega-3s in the cell membrane, that causes the whole pathway to produce products that are less potent. So this is like you have raw material, which is arachidonic acid, which is omega-6. Instead of that raw material, you give a weaker raw material, and that is omega-3. So when the products are made from omega-3, those products are weak in their action, and that reduces the potency of inflammation that occurs. So if you see here, when we have omega-3, instead of making PGE2, prostaglandin E2, we make PGE3. PGE3 is less potent and inflammatory substance. Similarly, instead of making prostacyclin, which is PGI2, we make PGI3. And excuse me, PGI3 is actually an antiplatelet. So it is an anti-inflammatory. Antiplatelet would cause platelet aggregation and thrombus formation. So it would help reduce the thrombus formation. This is beautiful. Similarly, when we have arachidonic acid, we'll make thromboxane A2. But when we have omega-3, we will make thromboxane A3. And thromboxane A3 reduces platelet aggregation as well. So that is also anti-thrombotic. So hypercoagulable state can be managed by the omega-3. Similarly, on this side, lipoxygenase pathway, when we make leukotrienes, we make leukotriene B5 instead of leukotriene B in the presence of omega-3 instead of arachidonic acid. And the leukotriene B5 is a less potent leukotriene. So that vasoconstriction and pro-inflammatory action is reduced. Finally, omega-3, when present in the cell membrane. They help produce resolvins and protectins. These molecules themselves are anti-inflammatory. So if you see here with the omega-3, there are anti-inflammatory effects that are very useful for long haulers. There is immune modulatory effect, which is also very useful for long haulers. There is cardioprotective effect, which is very important for long haulers. There is anti-thrombotic effect or hypercoagulable state suppression, which is also very useful for all of us, not just the long haulers. In addition to reducing the inflammation through VLDLs, and in addition to reducing the inflammation by helping with the fatty acid uptake and beta oxidation of fatty acids. So this is the function of the omega-3. I hope that this was useful. Tomorrow is my off. I was coughing less today as well because the air has really cleared up. And so tomorrow is my off. I will see you all on Monday. Stay happy and healthy. On Tuesday, we will have Nadir Purasan from Leronlimab. He has some more information about the trials. So we'll discuss that. And we may have some more guests as well next week. I'm going to talk about turmeric as well. Maybe on Monday we'll do that. So thank you very much. Stay safe and healthy. And I wanted to also report on the cool bean who had the symptoms of COVID. She is stabilized. She is stable. She is improving as well. So once again, thank you very much for your prayers for her. And I am happy that she is recovering. My question to all of you, and this is the last thing, and then I'll leave. My question is, have you and your family members experienced COVID-19? Have these videos helped? Have you been taking supplements? Or what has been your experience? So with this, thank you very much, and I'll see you on Monday.